This video is about quality management. We will be discussing quality management tools using Microsoft Excel, run charts, control charts, and Pareto analysis. Let's start with run charts. We have this data, and this data is about time it takes to process customers or to open bank accounts. So here's a problem. A bank manager is concerned about the long customer processing time in her branch. Although not sure what should be the optimal time to process customer, she noted the customer processing time for customers opening a new bank account using different combination of employees. She wants to explore what are the average and median time and if long customer times are due to variations in employee. The data collected over 4 weeks is provided here. Make a run chart and help managers in making a decision. The very first tool that we will use is called as run chart, and for that purpose just select this data and then click on insert and this one line chart and select this one. So this is called as a run chart, and the idea for this run chart is that it shows you a pictorial presentation of the data, how data is moving. As you can see here that on Monday this much number of customers they were processed, and on Wednesday this much number of customers were processed, that's very low, and then on Thursday again number of customers who were processed is relatively high. We can also refine it and add a little bit more information. So for instance, we can add here data labels, and if you select this line and click on add data labels, it shows that here on Monday 50 customers were processed, on Tuesday 49, and Wednesday 30. There is also a limitation of this one. This chart, although it tells us that how the process is running, but it does not tell if it is acceptable or unacceptable. 50, is it okay or is it too much of a time? And we want to know. For that purpose we will make a chart that's called as control chart. Control chart is a chart similar to this run chart, but the only difference is that we'll be adding here some control limits, an upper control limit and lower control limit. And for that purpose we need some calculation, and the first calculation is we will take average of this time. So average is equal to average here, and so it shows that average time is 40.44, and then the next thing is median. Median means taking the middle value of this data. If all this data is sorted in an ascending order or descending order, then we will take the middle value. The middle value will be, for instance, let's say these are 25 values, and if they are sorted in an ascending or descending order, the first 12 values they will be ignored, and the bottom 12 values they will also be ignored, and the middle value, the 13th one, that will be median value. We don't have to do it manually, Excel can do it for us. Is equal to median, and then select this whole column. Because I will be dragging it, so therefore I need to make these values absolute. So I will press here Fn F4 key, and as you can see here, when I press Fn F4 key, then dollar signs appear, which mean they have been locked, and then close parenthesis, hit enter. So the median is 42, and now I'm gonna drag it, so which means the same thing, the same median value. Then the next one is the range. For range is the difference of average value and time taken. Here it will be the difference of this average minus this time, and as you can see here, a range turns out to be negative 9.5. We don't need this negative. I want to get rid of this negative, and so for that purpose I will change formula, and I will just add here ABS, which stands for absolute value. B29, we need to make sure that it is locked, F4, so only average value is locked, and then 9.56 is, and then I will drag it, and then we also need to take average of range. I can take it separately or I can just drag it. That gives us this range at 6.3877. The next thing is to calculate upper control limit, and upper control limit will be equal to average, and here is average at the bottom, and make sure it is locked by pressing Fn and F4 key plus 2.66, which is a constant, multiplied by average of range. Here is average of range, and again make sure this is also locked by pressing Fn F4 key. So that gives us 57.43, and now I will drag it and we'll get the same value throughout. And the formula for lower control limit, as you can see here, is equal to average. Here is average, and make sure it is locked absolute value by pressing F4 minus 2.66 times average of range. This one, that's also locked, F4, and we get 23.45, and if I drag it, it gives us this lower control limit. Now we are done with all the calculations that are needed to make this graph. Now let's move to the next step, that's making graph. So I will select this whole data, and for that you can press Command Shift and page down key. The whole data will be selected, and then again click on Insert and the same chart, line chart, and click here. Now that gives us this control chart, and over here there are some redundant variables, and the first one is this one, that's range. We don't need it, so just click this one and then hit delete, and that will be removed. Now we have this control chart, and over here this line is called as upper control limit, and this dark blue line is called as lower control limit, and this orange color line is the central line or median line. These blue lines, they represent your actual data that's moving here. This graph shows all the values are oscillating around the median value. We also need to define this chart. So for instance, I will call it control chart. We can also add here some labels. We have two options. One option is that it shows us values. It will be 50 and then 49, 30, or other option is that you can also label it that it shows here Monday, Tuesday, Wednesday, Thursday, and Friday, etc. So let's explore both of these options. Select this line and then right click it and then add data labels, and then it's showing us these values, which is okay. But let's say rather than these values, I want this one, I want days here, like Monday, Tuesday, Wednesday, and Thursday. And for that purpose, again, I will click it and format data labels by right clicking. You get this one, and this time you see on the right side you have values from cell. So rather than having this one, I say I'm going to choose what type of label should be there. I want these one, so I select this one here and then click. I will uncheck this one, and as you can see here, it shows us name of days. Now the next step is how we interpret it. So as you can see, our problem was that a bank manager wanted to evaluate. So this is the time it takes to process a customer who wants to open a bank account. Process appears to be normal, and by normal I mean because there's a median line, orange line, and these data points, they are going above and below, and but they remain very close to that median value, so which means this process is okay. This type of variation is reflected by a concept that's called as common cause variation. The idea of common cause variation is that it is the type of variation which is natural and it's always occurring in a process. It is acceptable, and this variation that we see here is called as common cause variation, which means there is nothing wrong and you cannot control it. If you want to control it, you may have to change the whole process. That might be very expensive. So some of the characteristics of this one is that it is inherent to a process and are considered normal or natural variation, which means we should not be bothered by this variation. And then there is another type of variation that's called a special cause variation. So special cause variation is the one that's extraneous, which means the reason of variation, it comes from outside. It is not inherent to the system. These are common cause variation. A special cause variation would be that, let's say for example, if one point it goes beyond the limit, beyond the upper control limit or below the lower control limit, that would be special cause variation. And that special cause variation could be that, for instance, if someone takes very long because system was down. There are always variation among employees. Some employees do things quickly, others will do it slowly. So these type of variations are called as common cause variation. But if you find here some very conspicuous spike takes here goes up to 70 minutes or more, that would be a special cause variation, and that needs to be investigated. Now, the next thing is what managers need to do here. A manager does not need to be concerned too much because it shows there is normal variation, there is variation in process, but every process has variation and it is normal. There is nothing to worry about. And if manager still wants to improve this one, then maybe they need to change the whole process. And a change in process could mean, for example, making it online, where people will be filling form online, they will provide all information online, and they go to bank only to provide their identification. There are two types of errors in quality management. One is called as type 1 error and type 2 error. Type 1 error is called as false positive error, and type 2 is also called as false negative error. Let me give you some example very quickly. An example of type 1, that's false positive error, is that you are sitting in your apartment and all of a sudden fire alarm goes off. Later on you find that it was false alarm, there is no fire. So that will be called as false positive. Another example of a false positive would be that, for instance, if a cop arrests a person, an innocent person, thinking that the person is criminal, but actually the person is innocent. So that will be false positive, which means the cop made this false positive error. And what would be false negative error? Example of a fire alarm. Now imagine there is actually fire in a building and alarm does not go off. So that will be false negative error, which means alarm fails to give indication. The other person who is actually a criminal and cops release him thinking that he's innocent, that will be false negative error or type 2 error. Now in this case, what could be false positive or type 1 or type 2 error? If a manager is overly concerned that this process is not okay, but actually this process is okay, but if a manager believes that I should still improve it, and if that improvement brings extra cost and that may affect your resources, so that would be type 1 or false positive. On the other hand, another example would be that if there is a process that genuinely needs improvement, an inefficient process, but the manager believes that the process is okay, that would be type 2 or false negative error. Now the next one is called as Pareto analysis. Now, Pareto analysis, the theory of Pareto analysis is that Pareto was an Italian scientist and economist who developed this thing. He said that about 80% of problems in any setting can be attributed to 20% causes. And actually, it is a very natural phenomenon. You can see applications of Pareto principle almost everywhere. On a road, there will be a small number of reckless drivers, let's call them 20% or less than 20%, that will cause traffic congestion or traffic disruption. Most of the pollution on the roads is caused by a few cars. Similarly, in our everyday life, if you have a collection of clothes, usually there are a few clothes, let's say 20%, that you will be wearing 80% of times. Based on that principle, we want to prioritize problems or factors because we know that every organization has limited resources. You can channelize your resources accordingly. You can use your resources wisely. Now, for instance, let's say in a city, they found that most of water consumption, high water consumption, watering lawn, personal bathing, that's 106.7, swimming pool, they use 28.3 gallons per day. Now, if you don't know where actually problem is, you might be using your resources haphazardly. We want to use here a systematic approach, and the systematic approach is that we will use Pareto analysis, and for that select your data and click on insert and then click on recommended charts, and then at the bottom you will find this Pareto chart. Now let's label it. Now it shows that, for instance, if you look here, there is 80% and that's cumulative. So if we go back here roughly, it shows that these two problem, or maybe this one also, they are responsible for 80% of water consumption. The other one, they are fairly minor. So which means that if the city wants to address this problem, they need to focus on these two problems. Pareto analysis has given us a tool whereby we could scientifically and very objectively figure out what is important and where to start our process improvement. Now, if this Pareto chart is not available, someone can start with other factors. They might start with car washing. They would say, okay, we are gonna impose some taxes on car washing. But the fact is that car washing is not a big factor.